Okay, in this section we are going to look at forming ionic compounds. So we have to first talk about what an ion is so that we can talk about how we form ionic compounds. An ion is a positively or negatively charged atom or molecule. When an atom gains or loses electrons, the balance between positive and negative charges is unbalanced and the atom is no longer neutral. So for example, let's take a look at lithium. So lithium, we have to see its standard atomic notation, which is Li, its atomic mass is 7, atomic number is 3. So this is the standard atomic notation for the atom of lithium. So let's look at how many protons and electrons there are. Neutrons don't matter because they don't affect the charge overall. So protons would be equal to 3, and electrons would be equal to -3. So 3 plus, we'll say 3 negative. If we add those together, we get 0, right? So 0 is the charge on a neutral atom. So how does lithium become an ion? Well, remembering why atoms form ions, which is to become more stable. So to become an ion, it depends on where the atom is in the periodic table, but to become stable, they need to have a full valence shell. So they can either get a full valence shell by losing or gaining electrons. So let's look at lithium. Lithium on the periodic table is in, I'm going to go back to our other note here to find my periodic table. Actually, in the package, we have our periodic table. Let's find where lithium is. All right, so lithium is in the first column. So we know that lithium has 1 valence electron. So the options for lithium to become an ion, to get a full shell, is to gain 7 to look like neon, or to lose 1. So to gain 7 to look like lithium, to look like neon, or lose 1 to look like helium. So just like humans, atoms always go the easiest route, least energy expensive route, so in this case it would be to lose 1 valence electron. So this pattern follows all the atoms on the periodic table. So depending on what column they're in, they will gain electrons or lose electrons. So the first column would gain because it has lose. The second column would lose as well because it has 2 valence electrons. Column 13 has 3, so it would lose 3 valence electrons. Once you're halfway across, if there's 4, they can lose or gain electrons. So those are special cases. We will talk about those after. Column 15 has 5 valence electrons like nitrogen. So now they're closer to having a full shell. So it would gain 3 electrons to get a full shell. Column 16 has 6, so it would gain 2. And column 17 has 7, so it needs to gain 1. So that is the pattern to form electrons, and you will see this in a worksheet that I'll be giving you. So let's just focus now on forming the ion for lithium. So we saw that lithium was in column 1. So let's draw its Bohr-Rutherford diagram. So remembering what goes in the center of the Bohr-Rutherford diagram is the number of protons and neutrons. So there are 3 protons and 4 neutrons for lithium. We got neutrons by subtracting the mass minus the atomic number. So the first shell we know can contain 2 electrons, and there's 1 more, and now that first shell is full. The next shell has 1. So it's now going to become an ion. So this is the atom. It's going to become an ion by losing its 1 valence electron. So what does that look like? Well, this whole shell would be gone, right? Because it's lost that electron and the shell. So what's left is the nucleus. Nucleus will not change. And this one shell with its 2 electrons. And to denote that it's an ion, we put a square bracket around it. So we'll put a square bracket around it. And what is going to be the charge on this ion? Well, how do we figure that out? Well, here we looked at the protons and electrons in a neutral atom, but now it's not neutral. So let's do the protons and electrons for this. Our protons did not change. Our electrons did, however. We lost 1. So now we have 2 negatives. So our overall charge would be 3 minus 2, which would be plus 1. So this is the charge, and we would write that at the top right corner of the square bracket. So that's how we indicate an ion. So you'll get more practice of this on a worksheet that I'll be giving you in class. So how do we recognize ionic compounds? Ionic compounds form when metals react with nonmetals. So a metal and a non-metal react to form an ionic compound. And they are referred to as salts. So metals will tend to lose electrons and form positive ions, as we showed up here. Non-metals will gain electrons and form negative ions. So let's take a look at what that would look like with a Lewis structure, which are much more simple to draw than Bohr structures. So the Lewis structure for lithium is Li with 1 electron. So when it loses its 1 electron, it looks like Li with a charge of plus 1. Chlorine would be an example of a substance which would form a negative ion because it's a nonmetal, and it has 7 valence electrons because it's in column 17. So it's so close to getting a full shell, it's going to gain 1 electron. And when an atom gains electrons to form an ion, we indicate all the electrons because we've added 1 electron to the shell. Now its charge would be -1. So you can see the pattern of when you lose electrons, you get a positive charge, and how many electrons you lost indicates the charge. Whereas if you gain electrons, you gain a negative charge because you're gaining negatives, and the charge is equal to how many electrons that were gained. So that's how that works. That's the pattern for that. So a bond between a metal and a nonmetal is called an ionic bond. So we can say it's a chemical bond formed between oppositely charged ions. So there are some examples of some different types of ionic compounds that you need to know. So if alkali metals react with halogens, they produce salts. We saw that in our note on the periodic table as well. So sodium chloride and sodium fluoride are examples of this. So remember, this is in column 1 of the periodic table. This is column 17. So I'll put the names of these ones. Sodium chloride. Notice the ending. This would be chlorine, but because it's now formed this compound, it changes the ending to IDE. You'll learn more about this in grade 10. I just want you to know the few that I'm giving you. So sodium fluoride is this one. So those are alkali metals. The other are alkaline earth metals with halogens, and they also will form a salt. So these guys are in column 2 of the periodic table. So take a look at an example of one of those, and this would be MgCl2, magnesium chloride. You may wonder why there's a little 2. Well, it's because of the charges of magnesium, the charge on magnesium. So because magnesium is in column 2, it's going to form an ion with a charge of +2. And chlorine, as we saw before, has a charge of -1. So that little number at the bottom here actually comes from this charge right here. So you'll learn more about how to form these compounds in grade 10. I just wanted to give you a little bit of an intro to a couple of them. So the next thing you need to know are the properties. I noticed in your package it went to the next page, but that's okay. So some properties of ionic compounds. Number 1 is that they exist in a solid arrangement called a crystal lattice. If you think to sodium chloride or table salt, you know that they do look like little crystals, right? If you're not sure, next time you look at it, it looks a shiny little crystal. If you looked at it under, maybe magnified underneath your phone, and you could see it forms a little crystal. In terms of solubility, many ionic compounds are soluble in water. Why? Because water separates the positive and negative ions from each other. I'll show you a little diagram of that. So if this was sodium chloride and a crystal lattice, this is what it would look like. The sodiums and chlorines would line up. The positives and negatives beside each other. And it would keep going on and on and on. So you'd have another sodium, chlorine, sodium. The pattern is like that. So when water comes along, it actually attracts to the negative and positive parts of the salt, because water also has negative and positive parts. So water looks like this, and this would be a positive side, and this would be the negative side of water. So what would happen is the negative part of the water would attract to the positive part of the salt and pull it off. And then the positive part of the water would attract to the negative part of the salt, and that would pull, they would pull them off. They would attract, and then it would dissolve it. And that's how dissolving would happen. Okay? So that's a little bit about that. Now, the last property we'll look at for ionic compounds is conductivity. So ionic compounds are not conductors as solids. So you could not conduct electricity from a solid piece of salt because the ions are in a fixed position. But when they are dissolved in water, the ions are free to move around and therefore are good conductors of electricity. Okay? So that's a little bit about ionic compounds. And you can read this section and do a few of these questions, number 1, 2, 3, and 6 on page 231. The next thing we'll look at are covalent compounds in the next lesson. Bye for now.